two things I want to show you today. Friday we did components, U along V, and I showed you a visual of it. The projection is actually giving me the vector of that piece. So your components gave you a position. The projection is actually going to tell you what the vector is. And we're going to do visuals on each of these examples. You do not have to sketch these in your homework. I'm doing it just so you can see what it looks like. Okay? Projections. So U on to V. So we're going to write it like this. This is U sub 1 equals projection of U onto sub V. And this is going to be in your reference sheet. So there's two things you're going to put on your reference sheet. Yes?
Is that a V or an R?
V.
Okay.
V is in Victor.
I'm caught up now.
Okay. All right. So what you're going to do is you're going to take the dot product of U and V and the magnitude of V squared, and then you're going to multiply it by a vector V. So your last week you had a value, so the component was giving you a value. This week you're actually giving me what the vector is. So those of you who did your homework should understand, hopefully, what I'm saying, or have it sink in eventually. Got it down? So this will be on your reference sheet, so make sure you get it there. Alright, so let's just do some simple calculations before we do any application. This is number 30. Let's see if you guys remember how to do some stuff. U equals the vector 7, negative 4, and V is the vector 2, 1. Okay, so what I'm going to have you do is U sub 1 is your projection of U onto V, and then we're going to do U sub 2, and I'll show you what that is here in just a second. So the first thing is I want everybody to find the dot product of U and V. Those of you who didn't do your homework obviously do not remember how to do it. Some of you who did it are struggling. So can somebody explain to me what the dot product is with these two vectors? U times V, how do you do it? Yeah, so each entry, the first entry is multiplied together, the second entry is multiplied together, then you add that. So 7 times 2 plus negative 4 times 1, that's going to be my dot product. How do I find the magnitude? Quiz on Wednesday, by the way, sections 1, 2, and 3. Yeah, the square root of the entries squared. So V is here, so we're going to square each entry. Take the square root, and the formula says you have to square that. So the square gets rid of any radical that you might have. All right, so that's this piece, and then you're going to multiply it by the vector. So we're just plugging in values, putting together what we've learned in section 1 and already in section 2. So this is 14 plus negative 4 is 10. 4 plus 1 is 5. The square root of 5 squared is 5. And that's 2. Times the vector 2, 1. Good. And you get 4, 2. Good. And that's a vector. All right, now I'm going to start drawing what this looks like so you can get the visual. It's going to be kind of hard to see. It's kind of small. 7, negative 4. Again, the initial point is your origin. So this is U. V is a 2, 1. So that's your vectors U and V. Now I want U sub 1, which is at 4, 2. Notice that it is right along the V. And I'm going to read the instructions in the book because I want you to hear what it's saying. And then we'll do u sub 2. So it says part A, calculate the projection of u onto v. Well, that's what we just did. This is all the projection of u onto v. Okay. Let's see here. And then the next thing they say is the crazy part. Resolve u into u sub 1 and u sub 2, where u sub 1 is parallel to v, and u sub 2 is orthogonal to v. Alright, so u sub 1, what that's just saying is u sub 1 is going to be parallel to v. Well, this is here. It's on the exact same slope as v, and it always will be. U sub 2 is going to be orthogonal to v. What's orthogonal? How do you know something's orthogonal? It's what?
0.
What's 0? The dot product is 0. So how do I get u sub 2? Well, another part of this that is in your little blue box in your book is u equals u sub 1 plus u sub 2. So the vector u is equal to these two pieces of information. So u sub 1 is the projection of u onto v. So if I want to know what u sub 2 is, don't I just take u and subtract u sub 1 from it? Okay, so that's what we're going to say here. U minus u sub 1. Well, what's u? U is 7, negative 4. And you already calculated u sub 1. 4, 2. So what do I get? So this was part A of your homework assignment. This is part B. Yep, 3, negative 6, and that's a vector. 3, negative 6. And I didn't really draw it. All right, it is perpendicular. On an accurate graph, it would be perpendicular. So just to show you, so u sub 1, you just told me u sub 1 times u sub 2 is going to be 0. So let's figure out the dot product just to show that. 4 times 3 is 12. 2 times negative 6 is negative 12. Add those together, get 0. So they are orthogonal. So that's one way you can check just to make sure that your calculations are right. Here's the visual that you didn't need to draw, but what it shows is what they're asking is that u sub 1 is parallel to v, and u sub 2 is orthogonal to v. So that's what they wanted you to do. All you have to do is do the calculation. All right, now it's your turn. Let's do number. Let's do 32. Yes. You all do this one. So u is equal to 11, 3. Vector v is negative 3, negative 2. Do exactly the same thing we did here. Okay? Go. First thing is always the dot product. Doesn't it help you? Mm-hmm. Good. Yes. This right here. This is what you want. So first thing, find the dot product. No. I'm not going to create weight. Plus 3 times 2. So I'm thinking that's a negative 2, so that should make more sense. Okay. That's the top. We got close to that far. Go ahead and keep going. Now take it times that vector. Good. All right. Whoa. That's the vector. I'll put it down here. All right, -33 and -6 is -9. This is going to be radical 13 squared, which is 13. That's -3 times the vector -3, -2. Which gives me 9, 6. Again, I'll just draw the picture just to make sure we're doing it correctly. 11, 3. There is U. B is at -3, -2. Almost a straight line, but not quite. That's B. So U sub 1 should be parallel to V, meaning it just has the same slope. 9, 6. There's 9, 6. That should be a straight line there. That's U sub 1. Parallel to V. U sub 2 should be orthogonal. So how do we find U sub 2? What do we say to do? Yeah. So the vector U, 11, 3, minus 9, 6. And you get 2, -3. And that's orthogonal to V. Simple, just plug in the values and find your dot product, find your magnitude, multiply it by the vector. Make sure you understand U sub 1 and U sub 2, which ones they are.
Is that all it's on our homework?
That's the first part, and I gotta show you the second part.
Now the hard
And then we'll
stuff.
do an application. Which actually the application is pretty simple, the first one. Okay.
Application as in like trigonometry.
Well, yeah, there's some trigonometry.
Translation all.
Okay, the next thing I want to talk about, that is projections. Those are projections. Let's do work. You guys like to do work, right?
Depends what we're talking about.
As long as you get paid, right? Well, you're not getting paid. Yeah, okay. So, W stands for work. F stands for force. The dot product of F and D, D is your displacement. Let's start with some simple things. This is actually pretty easy. So the majority of your assignments are really just knowing your formulas and plugging in values. And we finally get to some applications. So not doing your homework doesn't help you. The four of you don't do your homework. Huh?
I'm sorry.
I understand. You're busy.
On purpose, it was all like, I'm not gonna do this, just to mess with Lockwood.
I know. Your heart was in the right place.
It's not that I didn't do it. I wasn't busy.
Oh, I understand.
I was, but yet at the same time, I had time to do it.
Okay.
I forgot.
That doesn't help your case.
I know. No, it doesn't.
All right.
I mean, honest.
Okay, let's do this number 36. We're going to do these together to make sure we can understand kind of what's being thrown at
That's what we
us.
need to be doing.
If the force is written as a vector in this form, 400I plus 50J, and we're going to move. The displacement is how much you're moving. We're going to go from point P, which is -1 to 1. Excuse me, -1, 1, to Q, which is 201. So here's section 1, being able to find the vector between 2 points. This is my initial point and my terminal point. First of all, find that vector quickly. What is that? How do you find the vector between 2 points?
It's the line like y2 minus
Except we put the x value first. Okay, so this is going to be 200 minus a negative 1 is 201. 1 minus 1 is 0. So that's your d, that's your displacement. That's a vector showing you going from one point to the next, how much it's moving. All right, now the formula is the dot product. So this is a vector, is 450, which you already know. So we're going to do the dot product of those things. So get out your handy-dandy calculator.
That part was given, right? The right
Yeah,
side.
these are given. This part right here is the given. You got to figure out how much work it takes to move whatever object they're talking about this distance with this much force. Well, you got a 0 in there, so that should be simple. How do you do a dot product? 400 times 201 is what?
80,450.
Plus 50 times 0 is just 0, so that's 80,400. I don't have any units on here yet, but that'll change. Usually it's in foot-pounds. Your distance, usually feet, how much something weighs in pounds, so we call that foot-pounds. Alright, so that's just the simple one. Alright, let me give you another simple one. You do it. Let's do number 38. F is negative 4i plus 20j. And you're going from point P010 to point Q525. Do the exact same thing. See if you can come up with the amount of work needed. Good. Who got that right? Who's still working? Simple? Alright, the majority of your assignment is what you just got done doing on the board. Pretty easy. Projections and work. But, unfortunately, we need to do some application.
Bleh.
So would you like another easy one except with a story problem? An easy story problem? Okay, I'm going to read it to you and then we'll put it up on the board. A car drives 500 feet. Oh, I don't want to do that in a minute. We'll do that in a second. The constant force of F being 2.8, the vector, 46. 2.8, there's the force given in the problem. Moves an object along a straight line from the point 2.5 to 11.13. Find the work done if the distance is measured in feet and the force is measured in pounds. Isn't anything different? Figure it out? Let's make sure you get it right. And then we'll do the other one. The last one. What?
I was asking what number problem was.
Yeah, I think, make sure that's right. Yeah, number 46. Make sure the stuff's on your reference sheets. got it right. What's the matter over here? Oh, you did? Just did more raise your hand. What did you earn today? Okay, alright, now, last problem.
How'd you get 8 on the second part? Not, yeah, in that one. 13 minus 5?
Oh yeah, I was looking at that.
Okay.
Yeah, that was alright. 13 minus 5 is 8.
So it's 11 minus, okay. Alright, I see that. Never mind.
Section 1, you're going to be given coordinates, and you got to be able to give the vectors. Okay? So that'll be on the test. Make sure you got that. And the quiz. Here's the story problem. The car drives 500 feet on a road that is inclined 12 degrees.
You lost me.
What'd you say?
We lost you with the 12 degrees because
Because then you use the pie chart.
it's trigonometry.
Cool.
There anything here that you haven't done? Let me help you with it. All right, you're moving the car 500 feet and on an incline of 12 degrees. As shown in, okay. The car weighs 2,500 pounds. So gravity acts straight down on the car. I'll draw a picture and you can understand. With a constant force of negative 2,500 J, find the work done by overcoming gravity. So let's go over here. So here's your incline of 12 degrees. Here's your car, and you're going to move it 500 feet. Okay? That's an awesome car.
Potato.
Some of you drive cars like that. All right. The force of gravity acting on this is straight down, and that is what. Where's my markers? Oh, come on.
Dude, what is on this?
Whatever.
I'm beating you a
At
pig.
least I do my homework. Why do you think they wrote it like that? Negative 2,500 J.
Who cares?
Why do you think they wrote it like that?
Because it's subtracting because it's pulling down.
It's going down, and the J is your vertical axis. Okay, so it's not going to the left or to the right. It's going straight down. So there's no I involved with this. Huh? Oh, this is number 48. Sorry. So your force in this case is 0, negative 2,500. Okay, that's your vector
Question, where does the actual number come from? Like negative 2,500?
in the problem.
Problem.
It's how much it weighs,
Oh.
and it's
Oh.
acting down on it.
Okay, gotcha.
Okay, gravity's pulling it straight down. If it says it's going straight up, then you're gonna look at it as
Okay.
positive.
Alright.
It's gonna be positive at the end anyway,
Okay.
because we're trying to get how much work is involved with this. We're not really dealing with negative work at the moment.
Okay. I just didn't really, I didn't.
Okay.
Good.
So we're gonna move this 500 feet. Now, displacement is your distance times your degree. So here's something that you might want to add for displacement when we're dealing with vectors. Alright, so my distance is 500. How do I get basically my x coordinate and my y coordinate? So for those of you who are wanting to know what it is, the vector is. And you've already done this. So it's the distance times your degree gives me my x value, or my I value if you want to use that. And my j value would be 500 times the sine of 12 degrees. So that's how you work out your displacement with angles. The component along U, or V, U along V, what we did Friday.
How do you do
Yes.
That's what we did Friday. Cosine is your x value, sine is your y value.
Is it always gonna be like that?
Yes.
Like, yeah, okay.
Yes, it is. Cosine is your x value, sine is your y value. For the last 4 chapters.
Yeah, I know that. I was just.
Okay.
I didn't know if it was gonna be like tangent or cosecant or
Well,
anything
if you're
crazy
missing
like that.
something, you can do it, but not for what we're doing. To set your mind at ease, this is the way it's going to be.
Yeah.
Okay. All right. So now you just have to do the calculation for work. Okay. So work equals F, the dot product of F and D. So you have 0 and negative 2,500. Okay, and the dot product between that and what is this? 500 times the cosine of 12 on your handy dandy calculator. Make sure you're in degree mode. What'd you say? 490? 489. And again, that's, you rounded it, right? Okay, so be careful when you're rounding. You're going to look at you have the answers. So when you look at the answers, just know that they may have rounded in different spots. So you got to be fairly close. And then what is 500 times the sine of 12?
104, yeah.
104. It's 104. 103.9.
Okay, I would have as many decimal places as possible. Okay, the more accurate you are, the better. So now you do the dot product. 0 times 489, that's just going plus 2,500 times 104. But your work is not negative. So 286,000 foot-pounds.
Foot-pounds.
Move it 500 feet. That's your distance in feet, and it weighs in a matter of pounds. So that's just approximation. 104 times 2,500. What'd you get?
260 pounds. Yeah. Wow.
286 or 260?
260.
Oh, sorry. I try to remember what we did earlier.
That's wild.
Now I have to read the picture.
That and I don't do math.
Yeah. Well, I figure if you're not going to do it, then why bother being accurate anyway?
I mean, because you got it wrong on the test
Oh, that's right. That's right.
or quiz.
Okay. So page 596. You did through 27, so we're going to do 29 to 49 odds.
You want us just to add this to the last one or something?
Yes, if you did it.
I mean, I'm gonna go back and do it.
Excellent. That was a great idea.
I will.
The more practice you have, the better.
That's the last picture.
So,
Yeah.
can we